Well, the motor constant represents how much torque a motor will generate per unit current, and that needs to be defined by first by finding out the torque at a rated current, finding out the maximum torque at rated current, and dividing the former by the latter. So we'll be needing a torque versus speed curve in order to find the maximum torque. We'll go down the data sheet. And so we have now found the required curve for the motor that we are interested in. That's K39B. We'll need to look at the red curve. We'll take a look at the full red line instead of the dashed line. So the full line would have a higher torque. So the maximum torque would be around 600 millinewton meters at a rated current of 1 ampere. So divide 600 millinewton meters by 1 ampere and you'll get the torque constant. So that's kind of a step-by-step process, that multi-step process that you have to follow. First, figure out the curve that you need for the respective motor that you are interested in. Figure out the curve that you need to look at. Find the maximum torque. When it comes to stepper motors, it would be the leftmost point on the curve, since torque starts at maximum and reduces with RPM. For a stepper motor, find that maximum torque and find out the rated current, divide the former by the latter, and you are good to go. So that's it with regards to parameterizing stepper motor. And once you find that and enter it, then that's then you are clear to proceed to the next stage of connecting these motors with drivers, connecting the electrical components with the drivers and the mechanical components with inertias and mechanical references. So let's move on to discuss about controllers. So for brushed DC motors, people typically use H bridges and PWM generators, and you would need these to control the direction the motor is operating in and control the speed of the motor. And then you can use active braking or coasting or freewheeling. And I asked the question within the physical class whether a PM BTC motor can be run without any kind of controller, with only the battery, a pair of wires, and the motor itself. And you all gave the correct answer that it is possible. On correcting power supply, the motor would run in some direction based on the wiring at a constant, at a, yeah, and upon reaching the max equilibrium speed, it would maintain that speed. So it's a single function only, then you won't be able to change the direction unless you change the wiring, and you won't be able to do braking or speed variation. It will just rotate at the equilibrium speed. So for our modeling purposes of this exercise, we won't be using H bridges and control PWM voltages, since we are taking a look at what would happen once a 12-volt DC power supply is used. But however, in 99% of actual cases, you will be needing H bridges and control PWMs provided from a microcontroller or 555 timer arrangement. And you can use these pre-built blocks from Simscape in order to model the effects of these control methodologies or control elements. Well, that's it with controllers for BD PMBDC motors. Let's move on to steppers. So now with stepper motors, what we really have is something called a stepper motor driver, and we will also need a signal source in order to signal to the driver. And the driver will provide electrical pulses to the stepper motor windings. Once again, I ask the question whether it's possible for us to run a stepper motor using only a power supply, a pair of wires, and the motor itself. And the answer was yes. However, that would result in that could be used only in very crude operational scenarios, and for 99% of the applications, you really do need a stepper motor driver in order for you to control the speed, the direction, and the acceleration if needed. So when we move on to developing the models for this exercise, we will be using a stepper motor driver since connecting a power supply to a stepper motor is insufficient. We'll be needing to generate some pulses, and without the stepper motor driver and a signaling source, we won't be able to obtain that pulse required to actuate the stepper motor. And in a similar manner to the parameterization of motors, you'll be needing to parameterize the drivers and control H bridges and PWM signal sources as well. But mostly these will be the nominal voltages and any phase differences or duty cycles of the signaling sources. And these would depend on the application that you are choosing. So I won't be able to give any hard and fast guidelines on what to use. However, I can say this: if you know how to wire the drivers and controllers and the motors together, you will have some idea of what specifications of the actual drivers are. Then you can use the specification of the drivers in the dialog boxes which pop up upon double clicking the blocks for the drivers. Well, that's it. Then we can wind up our sessions on motor parameterization, controllers, and how to connect controllers together.